Good evening. Good evening all. Today we will start gate through questions computer networks. Okay. We will cover some standard model questions in the computer networks. You can try this first model question. Given logical address of the computers, try this question. Good evening. Good evening, Umesh, Jubair, Rajak, Umesh Chandra, Arvind Kumar, Raman Singh, Srijal Patel. Good evening all. You can try this question. I am just giving the information what is given in this question. They have given the logical address of these computers C1, C2, C3. So please try all of you this question. These three computers are connected to all of you this question. These three computers. Okay. So are connected. These three computers are connected to this interface, and C4, C5, C6 are connected to this interface. C7 and C8 are connected to this interface. So I hope last year they asked this type of model 1 question. So we are trying to solve this question. Try. Yes, Kundan Singh, Mahapatro Ritu, Rishib Jain, Patak. Okay. Everybody is giving the answer is 3. Let us see. So it's quite simple. C1, C2 and C3, they have given the /28. /28 means what? 2 power 32 minus 28. So 2 power we can say 4, 16 addresses are possible. And you can see 97, 100 and 111 follows under one single subnet. So basically in that way we can solve, or the other way how you can solve is, by default router is a collision domain separator as well as a broadcast domain separator. So you can see there are 3 interfaces, so we can say there are 3 broadcast domains will be there, like that we can analyze. So 3 subnets are possible. So as everybody is saying A is the answer, yes, A is the correct answer. So possible subnets are how many? 3 subnets. Okay, A is the answer for it. Good, very good. Yes, Ishwar, correct. Whatever you are asking that question, that number of interface will be equal to the number of subnets. That's correct, correct. Okay. Yes, you can try the second model question. This is also, I think, in GATE 2022. This type of model question is given. This question. So you can try this question. So I am just giving the information in the diagram what is available. So there is a firewall connected to 2 routers, and one of the ending router, a web server, is connected, and the other router via interface Ethernet computers are connected. So you can try this question. Need not be in a hurry, you can solve it. Okay, it's not visible. Okay. Is it okay? Now you can see. I hope now it is visible. Anjali, I think now it is visible. I think Singh is telling Razak, Kundan, Kumar, Umesh, Ishwar. Yes. So everybody is telling B is the answer. It's very simple. Actually, what they are saying is, it is an enterprise network. That means this particular it is belonging to one of the organization, and you can see in that organization they have already made some subnets. And basically, what is the need of placing a firewall before the organization to protect from the malicious viruses or softwares like that? But we know very well in the class we used to discuss something like a packet filter firewall. The firewall is going to check only the headers, okay, it will not absorb the content of the data. So that's why separately antivirus has to be installed. Okay. Now the reason you can see they have divided as a subnets for effective utilization. So via this firewall one router is connected, and to this router again via this Ethernet switch the computers are connected. Sataksh Sen Gupta. Okay. So everybody is telling it's 4. Yes, correct. So how it is 4? You can see here we have 2 interfaces. So basically via this interface you can see it is divided into 2 subnets, you can say. See, whether it is divided as equal or unequal, we are not bothering in this question. So how we know whether they are divided equal or unequal? They will mention the network portion along with a mask, then we can know whether they are equal or unequal. So it is divided into 2 equal subnets. Now basically via this router again it is further divided. Okay. So this router is having 2 interfaces. So this is one subnet, this is another subnet. So general doubt you might be having, sir, to this firewall and this router we are not connecting any host. So how can you say a subnet? Even the point to point link is also call it as the subnet. So this is 1 and this is 2 and it is 3 and 4, you can say. So totally 4 subnets are available. Okay. So what is the answer? B. 4 is the answer for it. So general, not only in this question, in the workbook of the rank improvement batch, these model questions, many questions we have given, you can try. Okay. So basically where exactly the doubt you are going to get is, it's not only the computers which are connected to the interface of a router, router to router point to point link is also call it as the subnet. Yes, whatever you are saying, B is the correct answer. Yes, you can try the next question, next model question. So when you observe the previous model questions, especially in the classless addressing or in the form of subnetting, they are giving the actual block and they are asking the subnets. The following subnets are available in the range or not, they are asking. You can try this model. Which of the following can be the third address of the block? So they are mentioning that a third address of a block, if block contains 32 addresses. Okay. So basically how do you define a block? We use a word called block in case of what? The classless addressing, and block is nothing but what? Group of IP addresses. And basically in the IP address, first one will becomes net ID, ending one becomes the DBA, in between all going to become the hosts. Okay. You can try this question. So how to solve this problem? You can see they have given the /26. So this we can written as 2 power 32 minus 26. So it is 2 power 6. So 64 addresses are possible. So possible combinations can be 0 to 63, okay, 64 to 127. 128 to, okay, like that. Some if you made 191 like that, 64 addresses are possible. Okay, fine. But here you see they are mentioning that it is a /32. So when you say it is a /32, so here it should be mask should be 25 should be given. Okay, here it should be 27. 27 should be given, because if it is given as 27 only, it will be 32. Either one you can take it as. If you want to make, here it is 64, here it becomes the 26. So since you are taking 32, you make it as the 27. Okay, mask as the 27. Yes, C is the answer for it. How? Because it will start with 128. So this is the first address of the block. 129 second address of the block. 130 is the third address of the block. 130 is the answer. So generally in this question where exactly you might be doing a mistake is, you feel like since we are asking the third address of a block, so we are not asking third address of a host. If it is so, we start counting with the second one. Okay. So C is the correct answer for it. Yes, Ishwar, correct. Anjali, correct. Keshav, Kundan, very good. Yeah, you can try this third query. Sorry, fourth query. Just now we have done the third one. No? So I am just reading that question to make it, if it is not visible. It is mentioned that which of the following can be the last address of the block. It can be the last address of the block. If the block contains 32 IP addresses. Okay, try this one. Rishabh, Mahapatra, Ritushri, Patel, very good. Yes, B is the answer for it. How? See, it is mentioned that 32 IP addresses na, and they have given the mask as /27. So it is 2 power 32 minus 27. So it is 2 power 5. So it is 32 addresses are possible. And you can say they are asking the last address of the block, and also understand they are not asking the last host, last address of a block. Okay. So if we take those numbers 64, like it should be like the 0 to 31, 32 to 63, and 64 to 95, like that. And in that, this 159 possible combination, you are going to get that. So what is the answer? B is the answer, as everybody is solving. Okay, B is the correct answer. Patel, correct. Yes. Now see this is properties, so base properties of Supernetting. Based on this theoretical logics, last year they have given one Supernetting question. We try to solve that question also. For that they have given some statements, whether they are true or not, they are asking. Okay, please try this model. I am just reading the points. Which of the following rules are considered for correct form of address aggregation of networks? So basically address aggregation means what? Supernetting. So to join the networks, what are the possible rules should be followed? Based on that, last year they have given one question. The question is very lengthy, but solution is so simple once you know these rules. So try to analyze. Regarding these rules, I have explained in the class also, in the classrooms. Okay, you can solve it. Yeah, it is MSQ question. Kundan, Ishwara, Hari Krishna, Raman, Satakshi. Most of the people are giving correctly B and C. They have eliminated A. But you please check, are there any other answers are also there or not. I think Patel is giving the correct answer. Jain, Rishabh Jain is also giving the correct answer. Yes, Nishu Kumar, yes. Yeah, since we are MSQ, these are the general rules you follow. See, it's logic. Supernetting rules, everybody know. Address aggregation, everybody know that you have to join the networks. But while joining, you have to follow some rules. Okay. So you can observe that option A, it is mentioned that number of network joins should be multiple of 2. So it is false, right? It should not be a multiple of 2. It should be a power of 2, which is given in the statement B. So it is correct. Sen Gupta, Patel, correct. Patel, very good. Hari Krishna, Srijal, you check your answers. Akshay, good. Now see, option C, the prefix should be same. See, normally the prefix means the mask code. The mask bits are called as a prefix. Should be same for which should be joined. Yeah, that also should be correct. Na? Yes, prefix also should be. That means whatever the networks you are going to join, the starting bit should be same. If they are different, you cannot join them. So based on these points only, we try to solve one of the Supernetting question which is given in the last year. Okay. Yeah, many models we have covered in the class. Okay, now you see. See, option D, this is also correct. It's a very important. This is where exactly missing. So in the question, whatever the networks you are joining, if they have given in the discontinuous manner also, you have to make them as continuous to make it as a power of 2. And not only that, and whatever the networks you join in the given question, if that starting it is discontinuous, you have to make it as a continuous. So based on that only, this option D is matching actually. Okay. So here you see the first network should have zeros. That means suppose the Supernet bits are 2, 4 networks you can join. So what are the 4 networks? 0, 0, 0, 1, 1, 0, 1, 1. So the starting should be 0, 0. So even in that question, if 0, 0 is not there, we have to consider. Okay, and then we have to apply. Good, very good. Good evening. Yes, BCD, correct. Akshay, correct. Now see, based on this question, now we try the application based on that. Yeah, please try this question, take some time, don't tell the answer immediately. So they have given the table. Okay, so based on these 3 rules only, the Supernetting question, I hope this question last year model they have given. So it is not always the last octet calculations only will be given, it might be given more than that also, just like here you can see in this question. You can see they are talking about the aggregation only. Aggregation means what? So Supernetting. So you can see the first subnet they have given as 12.20.164.0. Okay, and in this problem the subnet mask is given as what? 255. Okay, dot 255.252.0. Okay, so this is the mask, and next hop is given as R1. Fine. So based on that, you can see here you have 255, 255, and here it is 252.0. Okay, so if you feel that it's not visible clearly, I will making. You can see. I hope now it is visible. Okay. Now you can see it is 252.0. So if I convert into this binary, I can write like this 164.0, I can write like this. Okay, so this 164 is nothing but what? 101 is 160 plus 4. Plus 4 means what? 100. So here it is 3, here it is the totally 6 bits are happened. So it is 00, you can write. .0. So here this particular 0, I can write it as what? 8 zeros. So basically the first row whatever you have, that is 12 dot to 20 dot, I am just writing in the form of what? Binary. Okay, now see this particular mask whatever it is given 252.0. So this 252 means what? Here I can written as what? 6100 dot this particular 0 means what? 8 zeros I can write. Okay, 8 zeros I can write. So to solve this problem, try to convert into binary, then you can have a clear idea. Keshav Gaur, good. Raman Singh, very good. Yes, if I take a second row, the second row I can write like this. So what second row? 12.20.170.0, and the given mask is how much? 255.255. This mask I can write like this: 255.255.254.0. Okay, you can take these ending 2 bits because remaining are 2 55s only. Okay, that means what? 170.0 you try to convert into binary. Okay, like that. So this 170.0 I can write like this. It is 101 is 160 plus a 10. 10 I can written as what? 1010.8 zeros you can say. Okay, fine. And you can observe that this 254.0 I can written as what? Okay, 7 ones and 0 dot, this 0 I can written as what? 8 zeros. Okay, like that. Raman Singh, good, very good. Yeah, this is the last year question of Supernetting we are solving. Fine. Now you can observe the third row. Third row is given what? 12.20.168.0. So if you take this ending, okay, 2 octet, this 168 I can, 101 is 160 plus 8. Plus 8 means what? 1 followed by 000. In between you can write 0. Dot 0. So how many zeros you can write here? 8 zeros. And for this the mask is 254. So mask is given as what? 255.255.254.0. This is the mask. Okay, fine. So now if you try to convert the fourth row, it is given as what? 12.20.166.0. So if you convert these 2 octets, because the mask is 254, and you can observe that second, third and fourth rows you have a 254. So this 166 I can written as what? 101 is 160 plus 6. Plus 6 means what? 110. You can write 00. Dot 8 zeros you can write. Okay, so now you have converted into the binary. So how to solve? So for this, just solving this problem, before I have given some statements, you can see you only told that these 3 rules you have to follow to form a supernetting. So power of 2 networks should be joined, and whatever the networks you join, for the first network it should have a zeros. Okay, that you have to consider. Okay, and what is the value that option C is what? The prefix should be same. So while solving, how to find out this prefix means it will be like this. See, so for the first network it is 1. Okay, here also 1. So prefix should be same up to that parameter you have to consider. See 1 0. So here also 1 0. Okay, so 1 0, here also you have what? 1 0, for this one also 1 0. Then if you further extend 1 0 1, yes, 1 0 1, 1 0 1, here also 1 0 1. Next extend one more bit. So when you form a supernetting, prefix should be same. That value you have to consider actually, up to same value. Now here you can see it is 0. Yes, here also it is 0. Here also it is 0. Here also it is 0. So up to now it is giving you an idea that these 4 networks can be joined to form a supernetting. So based on the options you have to consider. Now see, after that you observe here the 5th one is 0. And now you can see for the second network the 5th bit is changing. That means when you are taking that prefix 5 bits, you cannot include the second network. But if you observe this fourth network, so here the fifth bit is 0. So this gives you an idea that first network and the fourth network you can join them when you form a supernetting. Okay, understand? And you can see the first network is 164 and the fourth network is 166. Now here you see 10100, 10100. Can you further increase the prefix? Let us try. Now you can see here you had a 1. Here also you had a 1. Yes, you can increase the prefix. But now here you see next number is 0 and here it is 1. So you cannot form. That means what? For the first network, whatever the prefix is there, 101001 is the prefix, and here also 101001 is the prefix. So these two networks you can join. You can ask me, sir, why you are not extending the prefix further? Because you can see it is 0 and it is 1, so you cannot extend. So this gives you an idea for the host how many bits are left over. Here you can see 2 bits and here it is 8 bits. Here also 2 bits and 8 bits. So 2 plus 8, 10 bits are for the host. So if 10 bits are host, how you write? So 10 bits are host means how do I can write? I can write like this. How do I can write? 2 power 32 minus 22 is 2 power 10. So this 10 are the host bits. This gives you an idea that mask should be slash 22. Mask should be slash 22. That means while you are joining that first network and the fourth network, the mask value should be 22. So when you are forming a supernetting, those rules you have to consider and you have to join them. Now here you see, whatever the first network you had, that prefix is what here it is 00 and here you can see 10. So basically if you observe in the case of general supernetting, we are taking the 2 bits for supernetting. So you can join 4 networks here. So what are those 4 networks? 00, 01, 01 to yahan nahi hai. Okay, 10 and then 11. These 4 networks you can join. So since already 00 is there, so this becomes the first network. Okay, so now I can write like this. So 12 dot, okay, 20 dot 164.0/22 is the answer. First answer you can see. The MSQ you can say. First answer. Why /22? Because mask is /22. Okay. Now you can ask me why this 164 is taken. Because in this 164, 00 is the prefix. That you have to consider. You can observe in the previous statements we have given the rules here. The first network should have the zeros after prefix. Okay, fine. So what are the networks which are given in the problem? 00, okay, and 10. So you are joining first one and the fourth one, which are not available here, 01 and 11 not available. So basically here the concept is in this problem 164.0, 165.0, 166.0, 167. Okay, .0. These 4 networks you are joining. So for this 4 network the prefix is same and that prefix is this value. And while joining in the given problem, that 164 is given and here this 166 is also given. These two are not given actually. Okay, understand? So this option is available or not, you can see here option B, yes it is available. So why not option A, you can ask. See, if you say that option A, if I take 164 if I take, but you can see mask is /20. /20 means what? 2 power 32 minus 20 means 2 power 12 means 2 power 4 into 2 power 8. 2 power 4 means what? 4 bits becomes the prefix actually. That means here you should have 4 zeros. So you know the rule is when we have the 4 zeros here, 10, 10, 4 zeros, it becomes 160. But 160 is not available in the option. If it is given 12.20.160.0/20, then it is a correct, but that is not available here. So as per the rules of supernetting, in place of in the option A 164, if it is given 160, then you can take that is also answer. So I am telling you how to eliminate and how to get the correct answer actually. Okay, fine. So same like that, okay, if you observe, now you are in this problem, what you have done, you have joined the first network and the fourth network as a problem. Now see, if you try to observe now the second network and the third network, okay, second network and third network, very second network you can see 1 0 1 0, here also 1 0 1 0 is there. For further extend 1, yes 1, 0, yes 0. But now you can say after this it is different, you can say. What we have 1 0 is the prefix for this, 0 0 is the prefix for it. Okay. So second network and third network has the prefix as 1 0 1 0 1 0 you can say. And you can say for it is 1 0 and it is 0 0. Okay. For 170 it is 1 0, for 168 it is 0 0. So the rule of supernetting is whatever the networks you are going to join, further the first prefix should be 0 0. It is available here 0 0, that means it should be 168. Where is 168 is available? You can see it is available in the option D /22, like that. Okay. So in this MSQ question, what are the answers? Now you can say the answer is what? B and what? D. Okay, B and D are the answers for it. So now if you say, sir, why can't we take a C as the answer? See, even C is looking like a B, but observe the mask is /21. So /21 means 2 power 32 minus 21 is 2 power 11. 2 power 11 means 2 power 3 into 2 power 8. But 3 bits should be prefixed, with 3 bits prefix 0 0 0 is not available. So like that you have to eliminate. So you have solved this problem with the basic fundamental, okay, of these 3 points actually. So in case of supernetting, what you have to do? Only power of 2 networks can be joined. Whatever the networks you join, for that first one should be 0 0 should be there, like that. Okay. So this is the question I think last year they have given in the case of what? Supernetting. Good. Okay. Yes, Raman Singh. So here you have to observe, it's very simple. Suppose you say, if I say I will keep a answer 164, absolutely you can keep, but parallelly here the mask you can say it is a /20. That is the problem. See in the option A, 12.20.160 if it is available, then you can put A is also answer, because if I take a 160 means 4 bits is the prefix, 16 networks you are joining, 160, 161 like that. But they have given the starting itself is 164. That is the main problem actually, which is not possible. Because in the case of 164 you can see when I take a 4 bits 0 1 0 0 where there are no 4 zeros are not available. That is the reason you can eliminate A as the answer. Okay, understand? Then why B? See in the case of B /22. /22, that is what we are able to join, prefix is same. /22, 2 power 32 minus 22, 2 power 10, 2 power 2 into 2 power 8 means 2 bits. You can see the 2 bits is 0 0, so we are following the rule. So the basic logic is when you form a supernetting, the starting should have the zeros. Rohit, if you want you can merge. See, that is the problem. See, that's what I am telling. So if you want to, suppose in the same, if you want to merge, see, you can write like for option A, if it is given 12.20.160 if you have taken, then 4 zeros should be there. Okay, for 4 zeros it should be 160. If you have 12.20.160.0/20, then that will be the correct answer. Just to follow this those 3 rules. Based on this in the classroom I have solved like 7 to 10 model questions, like giving continuous networks, how to join them, given discontinuous networks, how to make it continuous and join them, and while giving, if I don't give zeros, based on that only we have given in the rank improvement workbook also we have given some questions based on that. Yes, correct. Okay. Now if you see option C 164.0/21. /21 means what? You can say option C. /21 means what? 2 power 32 minus 21 means 2 power 11. 2 power 11 means what? 2 power 3 into 2 power 8. 2 power 3 means what? 3 bits. So 3 zeros should be there. Where you can, suppose if you take a 3 zeros, you can take 168, then we have 3 zeros. But prefix should be same, but is not matching. That is the reason. So while if this here if they have given, so while solving, always try to pick up the prefix in this starting from left side 1 1 matching, 1 1 matching, next 0 0. Like that from left to right you approach and stop at a junction where it is mismatching, and based on that you try to join. If you try to join and if it is available in the option, you can put it. Like that you have to approach. That means you have to try to analyze from left to right until the prefix is same. Okay, until the prefix is same, join all them. If it is available in the option, you observe, put it on that. If it is not available, then what should be done? Out of all the networks, up to which values are matching, out of suppose 4 networks are given in this problem, suppose 2 networks prefix are matching, so your further you can join, you can do so. That is what we have done. If you say I will join all the 4, but that is not available in the option, like that. So even when we know the rules, how to approach means from left to right you have to approach actually until the number of bits are matching. Those networks only you can join them. Okay. So this is one of the model in the previous year regarding Supernet. So traditional way of giving the questions in the case of IP address, saying if you observe all the previous papers, they give about a subnetting, or they talk about a direct broadcast address, or they ask to calculate number of subnets. Like that we used to discuss in the class. But last year they have given such a model of how to join the Supernetting or address segregation. So for that we have to analyze in this way. Yes, Ishwar, thank you very much. Yes, B and D are the answers for this question. So here some of the questions are prepared based on the previous year models only. Diagrammatical approach, you can solve it. 7th question. Try to solve. Yes, thank you Raman, thank you Rohit, Ishwar, thank you very much. Kundan Kumar, Ishu Kumar. Raman Singh, Rishabh Jain, Suraj Anand, Sen Gupta. Yeah, most of the models in the workbook of rank improvement batch, the models we have taken, and some of the previous year GATE. So that generally the traditional way in IP addressing, how they are asking means either they will ask the number of subnets or whether these two hosts belong to same subnet, different subnets. But last year they have asked with a diagrammatical approach, like 2 questions. One is how to calculate number of subnets, or how to form a Supernetting, just like now we have done this model, and like calculating like this model also. Yeah, this model. So based on that, if you observe the workbook of the rank improvement batch, many questions we have given for practice. Yes, Akshay, Sen Gupta, Mansi, Patedar, Kundan, Pranay, Razak, very good. Patak, excellent. Okay, what is the answer? B and what? D. Good. Yes. You can try the next question. Yeah. So if you observe this eighth question, okay. So last year paper or 2 years back paper, these model questions they are giving. So just like in ISP, they will give some actual block, especially I am talking about a classless addressing. And in the subblocks, they used to give a different ranges, and that given range is allowable from the main range or not, they used to ask. Such type of questions are also they are asking. You can try that. This is one of the model. It is very simple, but in the actual model, so after calculating the last step, you have to check, you can see whether the given subblock is falling under that main block or not. You can try this question also. Yeah. Patel, Suraj Anand, Raman Singh, Akshay, Sen Gupta, Asuna, Jain, everybody is telling A and C. So why not B? Suppose if you observe the subblocks is 128. Okay, so so it is given as 128 in the option B, multiplied by each block is 1024. So it is 2 power 7 into 2 power 10. It is 2 power 17. It is exceeding the limit of the actual block, because you can see actual block is /16. That means what? 2 power 32 minus 16, it is 2 power 16 actually. So that's why B can be eliminated. So what are the answers? A and C. Very good. Okay, everybody has given the correct answer. Gurvesh correct. Mansi correct. Good. Ishwar. Very good. So if you observe the class notes also, these all models we have covered. Okay, in the how actually the problems are giving in the, if you observe regarding the CRC or flow control, error control, the approach how we have given the classroom, that is if you are able to solve all the models, the fundamentals, if you are strong enough, you can easily solve any question that is given. Okay, you can try 9th question. Yes, Nishu Kumar, correct. Yes, 2 power 16 maximum addresses, yes. Suraj Anand, Raman Singh, Akshay, Rishabh, excellent. Everybody is solving correctly. A, B and C. Yes, you can see A, B and C. Okay? No. So here there is small twist is there. Whatever you have put options A, B, C are not correct. Please check once clearly. I told clearly. Whatever everybody is put ABC, na, ABC is not correct answer. Ishwar. The small logic, small twist is there. See, company requirement of 60, this is one of the MSQ question. You can see here we have /26, /26, /26 everywhere. So it's obviously equivalent subnetting. So C is the correct answer. Good, very good. Company requirement of 60 host. In any 4 subnets are allowed. Yes, absolutely it is allowed, because it's /26, 2 power 32 minus 26, 2 power 6, 64 addresses, out of which these 60 are allowed. It's done. Okay, so here B is also correct. Anyway, since it is equivalent, it cannot be a variable length. Then where you have done the mistake, you check. Yes, Ishwar, now you have, okay, correct. Kundan, now Raman, now you are doing correctly. Razak, very good. Rohit, yes. See, the twist is, always remember the prefix C here, it is given as 6. So the 6 is not the prefix, the actual mask /26 is there, na? That is called it as a prefix. You are deciding the right side 6 bits, the right side 6 bits are the host bits, na? Those are not prefix bits. Whether it is a network or a subnet or a supernet, the left side bits will become the prefix bits in the case of classless addressing. Okay? Good, very good. So here this gives an idea. A cannot be the answers. What are the answers? B and C. Yeah, see, actually in the case of classless addressing, there is no distinguishability of network or subnet or supernet bits. We just use a common word that is called as prefix bits. You can distinguish network bits, subnet bits, supernet bits in the classful addressing, but as a whole in the classless we call it as a prefix. Okay, good, very good. Shall I explain once again? Yeah, see, here you see the number of prefix bits in each subnet is what? Here it is 6. Okay, but okay, here you see the prefix bits is what? Here /20. This prefix is a /26, but here it is given as 6. So when you have a total 32 bits, from left to up to 26 bits are the prefix bits, followed by the 6 remaining bits becomes the host bits now. So these 6 bits are the host bits actually. Okay, Gurbesh? Okay, good. Yes, Kundan Kumar, now you have told correctly, prefix bits are 26, good. Okay, Raman, okay. Thought 26 only, sir, but giving wrong answer at first. Okay, okay, nice. So B and C are the answers for it. Yeah, same, a similar model. So the idea of giving such type of questions, you can see these are mixing questions actually. Like here you should know what is a broadcast domain, collision domain. By observing a diagram, how many hosts are possible. So because in the MSQ they are mixing the questions and giving. Okay, try this 10th question. There are 3 networks connected to the router. Try. Okay, like that. See, in the case of classful addressing, you can directly tell whether they are talking about a network mask or subnet mask or supernet mask. But in classless, simple term is prefix. But with the help of prefix, you can tell. Okay. Then you had it up, sir. If you say with the help of prefix, how we know in the same problem network and subnet? It's very simple. For a subnet prefix, subnet bits will be more, prefix bits will be more. Suppose say /24 and /26 is there. Obviously, in the same problem, obviously /24 becomes the network, /26 becomes the subnet because more number of bits are available. Wherever the less hosts are there, that becomes the subnet now, like that. So ultimate target, whether you go for a classful or a classless addressing, whether you are able to give the IP address to in a network or not, to be identified logically in the network. Okay, like that. Okay, so Sen Gupta AD. Okay, some people are telling ABD, Vaibhav Patidar, Rishabh Jain, Rohit Kumar, Cecil, Razak. Okay, now see, number of broadcast domains in the above diagram are 3. Yes, it's correct. Why? Because you know very well, by default router is a collision domain separator as well as a broadcast domain separator. That is the reason cost of router is little bit high. And you know, where hub is a passive device, it is neither a collision domain separator nor a broadcast domain separator. You can see, since the router is having 3 interfaces, it becomes a 3 broadcast domain. So if you want to broadcast only here with the help of system, you can do. A system in this network, if you want to broadcast on the other network, you can do like that also. That is the power of the router, you can say. Okay, fine. Ishwar, very good. Gurbesh Lal, good, good. Akshay, very good. Razak, yes. So it's so simple. See, it's any system in a subnet 30.15.60.0/25. So it starts with 0 to up to 127. In between any host. Sir, why you take a 0 to 127? Because it's /25. So 2 power 32 minus 25, 2 power 7. Want to broadcast to all systems in a subnet. Which subnet? You can see they have mentioned that 190 the subnet. With the address means what? /26 means what? It will start with 192 and with 255. So they have given 255 only. So obviously it is a correct answer. Sir, how do you say? Because so simple, slash 26 2 power 32 minus 26 2 power 6 means 64 addresses. It is starting with 192 and with what? 255. So B is the correct answer. And the network comes under equivalent subnetting. Okay. So C is wrong, na? Because why? Just by observing a diagram itself, some questions can be solved. You can see it is slash 25, slash 26, slash 26. So mask is different. So it is a variable. So that is available in the option D. So what are the answers? A, B, D are the answers. Good. Yes, everybody has solved correctly. Yes, Sublak, correct. More number of ones in slash 26. Good. A, B, D. Yes, somebody is asking, sir, if you want to broadcast only in this network based system, for that anyway limited broadcast address is there, you can use that one. That means a system here, if you want to broadcast only in this LAN, you can use 255.255.255.255, you can use that one also. Okay? Like that. Now this becomes a system in this LAN, whatever you broadcast, that becomes a DBA of this particular network actually. Good. ABD is the answer. Yes, you can try the next question here. Yes, 11th question, you can try. Ishwar, Kundan, Kumar, Asuna, Akshay, Sen Gupta, Hari Krishna. ABC, everybody is telling ABC. Using subnetting. Okay. Option B, using private IPs in a LAN, public IPs can be effectively utilized. Yes. So option A, why using subnetting? It's so simple, na? Because when you go for a subnetting, exactly how many addresses you are going to use, you can use, and wastage will be minimum, and it will leads to more number of subnets. So remaining subnets can be given to some other network, whoever required. So this is true. First one is what? True. Okay. And if you observe option, using private IPs in a LAN, public IPs can be effectively utilized. Yes, because you see in every LAN networks, you use a private IP address because they are free of cost. Only for connecting the internet, you go for a public IP. Let us think in the other way. If there are no private IP address at all, so everywhere, for everything, for every system, you have to use a public IP only. So we end up with completing all the public IP addresses. So because of the private IPs, you can say public IPs are effectively utilized. It is also correct. Good, very good. And using PNAT. PNAT means what? Port NAT, network address translation. You have a static NAT, dynamic NAT, port NAT. Out of all port NAT, it is the effective utilization of the IP addresses. Because when you want to have an internet connection, now you are going to purchase only 1 or 2 public IPs. You don't purchase n systems, n public IPs when you have n systems. Just like you do in the static NAT or dynamic NAT. So directly one public IP, because remaining all the process can be distinguished with the help of what? Port addresses. So it is also correct. So even there are 3 concepts, separate things are there, but ultimate motto target is same, effective utilization of IP addresses. So A, B, C, all are answers. It is a MSQ question. Yes, Rohit, Suraj, Sen Gupta, correct. Yes, you can try this 12th question. So shall I read it? Okay, see here there is a router, 4 networks they have given. So try to analyze. So whatever the knowledge you had, you have to apply to get the answers. Try. Rohit, correct. Kundan is telling A and C. Yeah, subnet mask. They are telling, yeah, here you can also call it a prefix or a subnet mask. Okay. Vaibhav Patidar, Hari Krishna Reddy. Yes. Yes, A is the correct answer, one of the correct answer, because you can say /26 now. Okay, /26 means 26 ones followed by 6 zeros. 26 means what? 255.255.255. Already 24 are done. 2 more ones and 6 zeros is 192. So that is option A. Bobby Ado, Gurbesh Lal. Okay. Okay, option B. Company requirement of 120 hosts in any one of the 4 subnets are allowed. Now here you see it is not allowed, now 120 is not allowed. Why? Because you can say /26 means 2 power 32 minus 26 2 power 6 means 64 address only allowed. So how can you get a 120 host? So B cannot be the answer. Ankit Patel, good. Okay, option C. A system in the subnet 60.0 means where this one /26 wants to broadcast in the same subnet. It is using a limited broadcast address. That's what I have told you. There are 2 broadcast addresses, limited broadcast address and direct broadcast address. If you want to broadcast in the same subnet, you can go for limited. If you want to broadcast on the other network, you can go for the DBA. So here it is a limited. So this is C is the correct answer. Because here you are broadcasting in the same subnet. So the network comes under variable length subnetting. It is false because /26 everywhere 26. So it becomes a equivalent subnetting. It is not a variable length subnetting. So D is what? Wrong. So what are the correct answers? A and C are the correct answers. Yes, everybody has solved correctly. Good, very good. Correct. Yes, 13th, please try everybody. Which of the following is true in case of networking protocols? So you can say this question is a mixed question. Sometimes as a match the following, or for 1 mark question, they are mixing the questions and they are giving. Like in option A, they talk about HTTP, and in option B, they may talk about FTP. Option C, like fragmentation, they are mixing. So such type of questions, if you observe the previous papers, that mixing of the questions they are giving. Okay, you can try this one. Ishwar, Sen Gupta, Kundan Kumar. Okay, everybody is telling C. Let us see. Option A, what they have given, using dynamic NAT, DNAT, we have to purchase one single public IP for N systems in a LAN. So it is false now, because in the case of dynamic NAT also, if N systems are there in the LAN, then N public IPs definitely have to purchase. Okay, for allocating them, you use dynamically by using a count variable. That's a different story. But N system definitely, N public IPs definitely you are going to purchase. So cost is going to be high. So that is false, you can say. Okay, Kundan Kumar, Ankit, let us see. Option by default, bridge is a broadcast domain. This is also false. When does bridge is not a broadcast domain separator? If you convert a LAN into VLAN, virtual LAN, then only it will act as a broadcast domain separator. Yes, router is a broadcast domain separator. Spanning tree protocol is used to overcome loop between the bridges. Okay, yes, it is correct, no? Yes. Okay, fine. Why? So first of all, between the similar LANs you connect a bridge. For to support a fault tolerance, by chance if there is a failure of one bridge, to support a fault tolerance, you take one more bridge. That means between the similar LANs we connect more than one bridge. In doing so, because there is a graph structure is forming between the bridges, there is a possibility of loop or a cycle. That's why you have to apply the spanning tree, okay, the bridge protocol, okay, which is also called as a 802.1c. So for overcome the loop actually. So C is the correct answer. Yes, Rohit, correct. Bridge is a two-layer device, correct. Ajit Gupta is asking one question, I think. Sir, if you use a DBA for the same subnet, see, DBA of a same subnet, meaning itself is changing now. What is the meaning of DBA? I think Ajit is asking. DBA means what? Direct broadcast address. Means directed broadcast address. Means what? From a particular system, you are showing a direction, go to that network and there you broadcast. So within the same network, you always use a LBA only. You should not use a DBA. Ajit, I hope you understand. Yes, Raza, correct. In general, bridge is a collision domain separator. Yes, correct. Yes, one more model is given. You can try this one. It looks like a similar, but a small structure is changed. Try this one. 14th question. Yes, Ajit, I hope you understand. Yeah, now you can see in this question the prefix bits has given correctly. It is /27. So prefix is /27, which is available in option A. So it is correct. Number of hosts in each sub allowed are 30. Because it is /27. So 2 power 32 minus 27. So that means what? 2 power 5, 32. First one becomes net AD, ending one becomes DBA. 30 hosts are possible. Okay, so B is also correct. B is also correct. Yes, Hari Krishna correct. CSL, very good. Sen Gupta correct. Yes, if you observe option C, the DBA of all subnets should have last and 4 bits should be ones. When it is a /27, 2 power 32 minus 27, 2 power 5, ending 5 bits should be ones for the DBA, it should not ending 4. So it is available in the option D. So C is wrong and D is the correct. What are the answers? A, B, D. Yes, absolutely, everybody has done correctly. Yes, A, B, D are the answers. Ishwar correct. Rohit, Sen Gupta, Cecil. Good. You can go for the next question. Like, yes, try this question. This question is regarding the TCP. See, whatever I have discussed in the transport layer during a checksum time, I used to discuss this model. So if you observe the IP header also, end to end, even you do fragmentation, everything, all the fields remain same, but TTL is going to change. So header checksum is going to change. In the case of TCP, end to end, whatever you send as segments, okay, at starting you calculate a sender TCP checksum, at ending you calculate the receiver TCP checksum. That you know very well. So here this question they are talking about the IP address and the MAC address and the intruder. Here the intruder means what? A hacker, you can say. Try to analyze. Okay, Arjit, good. Ishwar is asking one good question, like, sir, for ending we have to add a padding bytes. See, since we are following the protocol, as we follow protocol should be same for the all the fragments. Otherwise, the code complexity, size of the code is going to increase if you write a code separately for the last fragment, no need to add a padding bits, it's a multiple of 8. When you make it as a unit, when you apply a rule, apply for all. Okay, Ishwar, I hope you understand. So when you do the fragmentation, you ask that for the last fragment, what is the need of adding the padding bytes? Because you are applying the rule for all the remaining fragments, it should be a multiple of 8. Obviously, for last also, we have to treat it as the multiple of 8. Otherwise, in the coding part, when you write a code for that fragmentation, for the last fragment, especially you have to write separately, it is increasing the size of the functions actually. Okay, Ishwar, I hope you understand. Now, what is this question? An IP mission queue has a path to another IP mission H via 3 routers are there. Here the routers. So H acts as a HTTP. See here, it is the HTTP server. So normally in the client to server applications, at the server, you are going to connect to a system of a server with the help of its IP address, which we are going to get with the help of ping command. Okay, later you can identify whatever you are connecting the system, which services are open, whether they are passive or not, with the help of nmap command you can use. Okay, like that. So what they have given, Q connects to H via HTTP and downloads a file. Session layer encryption is used. So basically, out of all the layers, if you are going for a TCP IP model, encryption is done at the application layer. If it is a OSA model, encryption is done at the session layer. And a shared encryption protocol. Which information? Intruder means what? Hacker. Okay, or a sniffer also you can say. Can learn through sniffing at R2. So here it is snooping at the hacker is snooping at this point. So this is the question that they are given. So try to analyze. So whenever we discuss in the classrooms also, if you observe the IP protocol, even after we discuss all the fields, the source IP, destination IP, whether it is changing in between or not, we will be knowing when I talk about the TCP checksum. At that time only we will be also knowing about the MAC address, why MAC address scope is local. So based on these 2 points only this question has been designed. Okay, see, MAC address scope is local, so at every hop it is going to change. So whenever you are sending the packets, end to end, source IP and destination IP remains same, then only the source is able to identify that system server, and server also can give replies to that system. That's the thing. See, when you do this, NATing is a completely different story which you do locally in a LAN, but end to end when you talk, IP still remains same actually. And here, the interview question normally ask why we can't use a MAC address for a communication end to end in the internet, because scope is local. At every hop MAC is going to change. So basically whatever you send a packets at the ARP level, the MAC is going to change at every hop. And these things we used to discuss when we talk about a TCP checksum calculations, why MAC is changing at every hop, end to end why IPs remain same, that we are going to discuss. Based on that this question is designed, right? So everybody is telling it is B. First of all, you see physical address of Q can be known. See, hacker is at R2, so he is connecting locally to R1. So definitely while you get a packets, he will be knowing about the MAC address of R1, but an intruder hacker cannot know the MAC address of this particular system Q, because the LAN is changing, because the MAC address is going to change at every hop, you can say. Okay, you can see option A, MAC address means physical address only. So physical address of Q can be known, hacker cannot know the physical address of Q, he can know the physical address of R1, you can say. So A cannot be the answer. Yeah, physical address of R1, that MAC address of R1 can be known. Yes, it is true, because the intruder is snooping at this point actually. Physical address H also cannot be known. So what is the answer? B is the answer. So even it is a direct question, until and unless you do that analysis what at the TCP will end to end, what is changing, which fields are remain same, why TTL is decremented every router, okay, then only you can solve this question. But it's good everybody has given the correct answer. Good. Good. Not very good. Akshay. Sen Gupta. Okay. Yes, Ishwar. Good. Yes. Now, based on that only, based on the same thing, you try the 16th question. Same model they have given, but try to understand what they are talking. See, generally with the help of IP address, you can contact that particular system with the help of DNS. But whether which ports are open, to know that you have to go for the Nmap protocol actually. To know the vulnerabilities of the system, or you are genuinely contacting that system, that's okay, directly you can contact. But you should know that rules, na? Like, try this one, 16th question. Yes, Kundan Kumar, that's what I am telling now. Why you don't, it's whether to add, whether you don't add, it depends upon the protocol actually. Since you are forming as a adding bytes, for the last byte also you can add. Yes, Kajal, correct. Pratik Singh, Raman Singh, Kundan Kumar, Vaibo, Nad. Everybody is telling it. Now here is same question. See, IP address of a queue can be known. Yes, it is true, because the intruder is snooping at this point, and whatever you send the packet end to end, source IP, destination IP will not change. So you have to remember those things, whatever you have done the analysis, like you can see identification number, DF, MF, fragmentation asset, end to end will not change. Even if you do fragmentation, TTL will change, end to end, source IP, destination IP will not change, which you have learned in TCP like that. So here you see IP address of queue can be known. So A is the correct answer. But here you say physical address of a queue, physical address of a Q and H cannot be known, because the hacker is intruder is snooping at this point, and the MAC address is changed at every hop. He can know the MAC address of R1 and R2 because directly connected to that LANs. So what is the answer? A is the answer for it, just opposite to the previous question. Okay, like that. So this will give you an idea why the communication is normally done. The logical system in the network will be known with the help of IP address, but not with a MAC address. Asuna is telling in the option H is available, that is also correct, IP address. Yes, that is also correct, Asuna, correct. If H is also available, IP, that is also correct. Ishwar is asking session layer encryption means what? Now see basically the data whatever you, I think Ishwar is asking. When the data is start moving from application layer, a header is attached, and then it will come down to the presentation layer, one more header, and at session layer one more header. So for all these three layers, now the encryption is done. Okay, that is called session layer encryption. But for the remaining thing, so are you understanding? See, the data whatever you get from the above layer, application header is attached, then the presentation header is attached, then the session layer. So for all these things encryption is done. But after that the transported is not. That is the meaning of the session layer. Suppose say normally in the TCP IP model encryption is done at the application layer. So only for the data you are doing the encryption actually. Okay. So OSI model is following that session layer encryption, and TCP is following that encryption at the application layer. That's the only difference. Okay. Fine. Yes, A is the correct answer. Yes, you can try this 17th question. So in the class we normally discuss three protocols like RARP, what are the drawbacks, then the next version called boot ping, there what are the drawbacks, then we go for the DHCP, the present days everywhere we use dynamic host configuration protocol. Based on that they have given one question. So try this question. No, presently as for the statement there is no IP encryption, there is a IPsec protocol is there. So we can't say always the encryption word, IPsec protocol, that's a different story. Okay, Ishwar? So in a generalized, there is a application layer encryption will be done in that case of TCP IP model, session encryption is done at the by the OSI model. But there is separate protocol called IP security. Okay, that will be done separately. We cannot say encryption at the application IP protocol layer. Kundan, Kumar, Razak, Patedar, Mahapatra, Pratik Singh, Keshav, Hari Krishna. Yeah, very good. What is the answer? DHCP. D is the DHCP means what? Dynamic host configuration protocol. Dynamic host configuration protocol. You can see in this question, they are not just asking for assigning the IP address. See, it is not, they are not asking just assigning the, if they ask only IP address, all three are correct. I mean, I am talking about RARP, boot P, these all are correct. See, IP address, subnet mask, DNS server, that means gateway address, okay, automatically from a server, without involvement of the user, from the server, dynamically you get all these features actually, with the help of what? DHCP. Okay, understand? So this is a, okay, this RARP boot P, you will get an IP address, but you know RARP cost is high. In the case of boot P, dynamic assignment is not possible, but in the case of DHCP, dynamic assignment as well as all these subnet mask, DNS server, diff, automatically you are going to get. And even the main purpose of DHCP is to get an IP address. How well this DHCP works at the application layer actually. How well the DHCP protocol will differ from the remaining, I hope so, like HTTP, FTP, like DNS, like that. The difference is in all the protocols, one of the port will be dynamic port and the other port will be the fixed port. But if you go for DHCP, both will be fixed ports, and those ports are 67 and 68. That is how the DHCP will be distinguished from the remaining all the application layer protocols. Okay, so here D is the answer. Good, everybody has done correctly. No, Ishwar, IP encryption will not be done. They will be saying IPsec, IP security they can tell. Okay, that means only for the IP header they do the encryption. Yes, you can try this the next question. Eighteenth question. Yes, it is a MSQ question. Try. Yes, Hari Krishna, correct. Both are used the fixed ports, 68 and 67 they are going to use. See, when you are calculating the number of fragments, TCP header is also part of the data. It is, I think Ishwar is asking that question. The reason is when the data is coming from transport layer, where you will call them data is packets in the network layer. What is a packet? IP header and data. In the data what we have? TCP header and data. So TCP header is also a part of the data. Okay, Ishwar? Like that. Jubair, Akshay, Vinay Pant. Okay, good, very good. Sen Gupta, Patedar. Razak, good. Very good. What are the answers? A, B. All are answers correct. All are correct. So this during the time of flow control pulse we are going to discuss normally, because the ACK timer for the cumulative ACK should not be so small, so that remaining frames might not have arrived, and it should not be so large. So the initial timer is going to expire, and in that illusion the sender is going to resend again the packets actually. It's a GATE exam is not so large like 20 hours or 12 hours, so that everybody end up solving the question. So in deciding the rank it becomes difficult, and it should not be so small like 15 minutes or half an hour, so that nobody has solved all the questions to decide the rank. So it should be moderate like 2.5 hours or 3 hours. So like that it is. Okay. So based on that they have given, so all are correct. So A, B and C. Okay. Good, very good. Yes, you can try this 19th question. It is regarding the CRC, I hope, and try to apply. Yeah, do it slowly. Some people are telling A, some people are telling B. So observe the question. If you had a doubt, take some inputs actually. For example, see if I take X as a generator. So this I can run as what? 1 into X power 0, 0 into X power 0. So take the coefficient, so 1, 0 is the generator. So when the generator is 2 bits, how many padding bits you are going to use? N minus 1, that means 1 padding bit. That means for this 1 padding bit you are going to use, so X power 1, so 1 padding bit, like that. Suppose if I take, if you had X plus 1, okay, if I take like that, because it's given X power N plus 1, so this I get written as 1 into X power 1 plus 1 into X power 0. Okay, so that's why don't tell the answer immediately, try to analyze. Small such type of twisting questions also will be available. Okay, like that. Okay, so if you take the coefficients 1 and here also it is 1. So when the generator is 2 bits, how many padding bits you are going to use? 1. So here it is X power 1, so 1 padding bit is utilized. So by observing the generator, suppose if I have taken X square plus 1, so how do I write? So this I can written as 1 into X square plus 0 into, okay, X, because it is not there na. So 1 into, okay, X power 0. So what is the generator now? 1, 0, 1. Now generator is 3 bits. When the generator is 3 bits, how many padding bits are attached? 2 padding bits is utilized. 2 padding bits. So here you can see it is power is 2, 2 padding bits. Power is 1, 1 padding bit. Power is n, then how many padding bits? N bits are attached. Like that you have to generalize. So even we know the solution of solving the CRC or whatever might be, even you had a doubt, so take some examples and solve it like this. Okay, like that. Yes, Kalyan, correct. Okay, like that. Akshay, you can see. Say X power 1 plus 1. So 1 into X power 1 plus 1 into X power 0. So 1, 1. So 2 bits are there. When you take 2 bits, padding bits are 1. When the bits are 3 bits, padding bits are 2. Means what? If the generator is n bits, n minus 1 padding bits are attached. But here you see it is power is X power 1. Power is 2, 2 padding bits. Power is 1, 1 padding bits. Like that. They are talking about the power. Okay, so A is the answer for it. Okay, good. Yes, now you can solve this one question. This is the analysis question they have given. So whatever the knowledge you had in the IP protocol, apply here. So you will get a correct way of analyzing. So it is a MSQ question. Try. WAN network. So the infinite rotation is going to become a finite because it will rotate until TTL value becomes 0. So A is what? Correct. Packet will be dropped network once TTL value becomes 0. Yes, this is also correct now. Once a packet is dropped, ICMP protocol will come and will take a source IP and inform to source. And when ICMP is informing back, it is also a type of packet. And how, as a user, how do you know that is a ICMP packet? For that, protocol field value will be how much? 1 will be there. Okay, good, very good. Sen Gupta, Kundan Kumar, Vinay, very good. Bobby Yadav, good. Checksum is provided only for the IP header, so the packet will go to a correct destination if it reaches. Yes, it is a fundamental logic actually. So why you provide a header checksum? So that packet will go to the correct destination if it reaches. So packet will never go to wrong destination. Packet might either drop, or if it is reaches means definitely go to correct destination. Why it will not go to wrong destination? When checksum is wrong, immediately at the next upcoming hop only, the packet will be dropped. So that is also correct. Okay. So this is a standard model which can be given in the MSQ question. So once the concepts are cleared and you are able to link every question, you can solve it. Okay, like that. Yes, you can try. This is also one more MSQ question. This is also regarding the fields of the IP protocol. Regarding what? Fields of the IP protocol. Try. Maximum 9 intermediate router addresses are placed using the source routing option. Yes, see, you can see the logic is what in the case of options and padding. Case of options and padding. Okay, 40 bytes are placed. So 40 bytes means what? 4 into 10 bytes. So this I get written as what? 10 rows. So even there are 10 rows, each row of 4 bytes, first row is mentioning the option. So remaining 9 rows and every row you can place one router addresses. So maximum 9 intermediate routing addresses are possible when you don't use with the other options. So it is true. And the NOP option is used to fill the gaps between the that is also true. So A and B. Record route option used to fill the gap. So it says false now. Why? The purpose of a record route option is what? For finding out what are the intermediate routers, so that these values will be used in the source routing option later actually. So you know by default packets not only forwarded by the router, sometimes source also. And how does the source know the entire part? With the help of what? Source routing option. Okay. Good, very good. Jubair, correct. Vinay, Soras Anand. Good. Yes. Try this question. Nine, shall I explain once again? Now see, it's very simple. Basically, in the case of IP protocol, after the basic header, you have the options of how many bytes? 40 bytes. Okay, because you know 20 to 60 bytes, now 20 is the base header and 40 is the options and padding. So 40, how do you write here? 4 into 10. Na? So you know this I written as what? 10 into 4 bytes. Okay, so these 4 bytes is single row. Na? That means what? 10 rows. So even you have a 10 rows, one row is for mentioning the label. So remaining 9 rows. Okay, remaining 9 rows you can place the router addresses. That's why maximum 9 intermittent router addresses are possible. Okay. Try this question. Yeah, see, if you observe some of the previous papers while solving, you will had a doubt most of the time. But whoever listened my class notes, you can clearly understand how to solve this problem. So many people will be in illusion the TTL will be decremented only at the router. No, at source also it will decrement. Based on that, this question is given. One of the gate question also, you should understand that at source also TTL value will be decremented. You can ask here now, sir, why TTL value will be decremented source also? At the TCP point, we have discussed like application layer, transport layer, network layer, data link layer, all the layers are available at a source also. And you know TTL is a part of network layer. So obviously at source also it is going to decrement. Okay. Soras Anand, Bobby Yadav, good. So basically how to solve this one? It's very simple. Here you decrement the TTL value and calculate a header checksum. Why you are calculating IP header checksum? Because it decremented. So once the packet has reached at this interface, again you calculate for what? For verification whether to accept or whether to not accept. Because once you calculate here the header IP header checksum is equal to received header checksum, then only the packet will be accepted, or else packet will be dropped. Once it is dropped, ICMP protocol will come and it will inform to source, that you know the story. So TTL is only decremented at the outgoing interface but not at the incoming port actually. Here you decrement, calculate the header checksum. You are calculating here because TTL value is decremented. Here you are calculating for verification. Okay. So calculate for verification, calculate for verification. So 4 times header checksum is calculated. TTL how many times it is decremented? 1 and 2. Okay, 2 times. Is it clear? 2 and 4. Kundan Kumar, which layer is assigning a TTL value? Because all the layers are visible, now it will be like this. If you remember in the class, at source, application layer, transport layer, network layer, data link layer, physical layer, all the layers will be available at source only. So at that network layer where there is a IP header and the third row left side there will be a TTL value. So definitely at a source also it is going to decrement. And anyway at the router you know it is a 3-layer switch. Okay. If you observe the class notes, I have given you correctly regarding this logic. Good. Raman Singh, very good. Kundan Kumar is asking, sir, who decides initial TTL value? Very good question. So there is a command called trace route command. In the class I have explained. By following that particular command from the source, the destination is how many hops far away it is going to calculate. Based on that, initial TTL value will be calculated. Because of that only, TTL value will never become a 0 without forming a loop or a cycle. Okay, Kundan? Okay, fine. So in this case, what? C is the answer. Once again, I am explaining. Here the TTL value is decremented, calculate a header checksum. Once it is reached, calculate again header checksum, matching, accept, mismatching, drop. Again forward, TTL value decremented. So here and here it is decremented. Here, here and here 4 times you are going to calculate a header checksum. So what is the answer? 2 and 4. So C is the answer for it. Yes, Kajal, correct. Yeah, you can try this particular question. It is regarding ICMP protocol they have given. Try. You know the ICMP is a supporting protocol for the IP protocol. IP protocol is a connectionless unreliable packet. So when the packets are dropped, so dropped packets will be handled by the ICMP. Even ICMP is not handled properly, there is an end-to-end TCP global ACK will be there. Okay, or you can say the global ACK which is provided by the TCP will act as a fault tolerant to the ICP ACK whatever it is lost. Okay, so you can try this question. There are different messages will be there in ICMP. Yes, everybody is solving. Kundan, Hari Krishna, Ishwar, Nad, Abhiram, Jubair, Rohit. Raman Singh. Option A, what is giving? Source quench message will be transmitted by the ICMP when noise modifies IP header bits. Okay, option A is wrong now. What is the purpose of source quench message? You know very well. When more number of packets are transmitted in less amount of time, then the router buffer will be full in no time. Then the router will be congested. Then some packets will be dropped. Then ICMP packet will take the source IP from the dropped packet and inform to source by sending source quench message. So source quench message is transmitted whenever the router is congested, but they are telling that parameter bits are modified, so A is wrong. Option B, in case of redirection message of ICMP, packet is dropped in the network. It is also false now. You know very well, out of all the messages, especially in the redirection message, okay, packet will never drop. Packet is redirected. So initially it may direct in a wrong way, later it will be redirected in a correct direction. In that situations, ICMP is going to send what? A redirection message actually. So in all the remaining case, packet will be dropped, but in the case of redirection message, packet will never be dropped, it is redirected actually. And you can see option C, parameter problem message is transmitted when noise modifies the IP header bits. Yes, so this is the correct answer actually. Okay, so just before this problem you can see regarding this one only. Here, if noise modifies header bits, then the calculated header checksum will not be equal to received header checksum, packet will be dropped. Then ICMP will inform to source a message called parameter problem message. Okay, C is the answer for it. Good, very good. Yes, Asuna, correct. Vinay, very good. Kundan, Patel, very good. Okay, you can try this next question. It is also regarding this IP protocol header they are asking. Try. This is also some application question. Yeah, total length field of IP packet. See, you know, whatever the IP header which is available for a packet, that IP header is also available for the fragments. So they are mentioning that total length field of IP packet will give you the starting address of the fragment. No, it will give the size of the packet. So here you can say A is what? Wrong. Then how you get a starting address fragment? In the second row, right side, you have a fragment offset field. Fragment offset multiplied by 8 will give you the starting address of the fragment, but not the total length. Yeah, whatever the fields which are available for the packet, same fields will be available for the IP header, fields available for the fragment also. So the meaning will not be changing. Okay, the size is going to decrement for a fragment. Yeah, when df is equal to 0. What is df don't fragment? If you are not fragmenting means it is packet. So when df is 1, it is a packet. When df is 0, it is a fragment. And mf is 0. mf is 0 means what? You know very well. For all the intermediate fragments, starting from the first one, mf value is what? 1. But especially for the last fragment, mf value will be 0. So obviously the last fragment of the group, yes. So B is correct. B is correct. Yeah, it's an MSQ question. And if you observe this option C, they have given the header length is what? 0011. It is given. So because you know in the protocol for the header length only 4 bits are available. So this is nothing but what? 3 rows, you know. And you know the header length will give the size of header. So 3 into each row is how many bytes? 4 bytes. So 3 into 4 means how much? 12 bytes. You know very well 12 bytes is the invalid header, because the reason is in the case of IP header, minimum header is 20 bytes, maximum header is 60 bytes now. Okay, like that. So they have mentioned that the header length 001 is an invalid header. Yes, it is true. So you can say C is the correct answer. C is the correct answer. Patel, Asuna, Raman Singh, Nath, Rohit, Anand, Kumar, very good. Everybody has done correctly, good. So B and C are the answers for it. Excellent. Okay, so you can try this question. So during the doubt session, some of the students used to ask me, sir, what is the meaning of outstanding frame? So this question will give you an idea. During the flow control policies, we generally use a word called outstanding frames. So try to analyze. Yeah, multiple choice question. Yes, Raman, very good. Thank you. Raman Singh, thank you very much. The number of outstanding frames will indicate the number of packets in a buffer. So basically, you know, from the sender's data link layer, from the sender's network, you get a packets and you place it on the buffer. But the protocol will decide from the buffer how many packets you take and transmit on the channel. Okay, and that the limiting factor is the window protocol. Suppose if you go for a 3-bit sequence number 2 power 3 8, sender window size will be 7, receiver window size will be 1. Then from the buffer you will take a 7 packets, maybe more also available, but will take only 7 packets because the protocol is decided 3 bits. Then 7 packets are transmitted. So after transmitting 7 packets, you wait for the acknowledgements. So after transmitting and waiting for the acknowledgements is called it as the outstanding frames. So you can see the number of outstanding indicate number of packets in the buffer. So this is going to be false now. So A is okay. So A is telling only whatever the packets available in the buffer. That's wrong. Yeah, everybody is telling it is B. The number of outstanding frames will indicate the number of frames that are transmitted and waiting for their acknowledgements. Yes. So B is the correct answer. Okay, and here you see retransmit from, it is also false. But see one important point, you observe one important point. Suppose you transmit 7 frames and waiting for the acknowledgements. So now the outstanding frames is 7, no doubt in it. But as you get the AC case, the outstanding frames is going to decrease. For example, now you transmit 7 frames and waiting for the acknowledgements. After getting one ACK of the first frame, then the outstanding frames become 6 only. Okay, so as you get the ACKs, outstanding frames are going to decrease. Okay, that's a different story. If newly packets are readily available, you can start sending again. I mean, you can start sending the new thing, then you can increase the outstanding frames. But remember one very, very important point. The number of outstanding frames will never increase that protocol which is guided by that sender window size. Okay, suppose if you take a 4-bit sequence number, sender window size will be 15, receiver window size will be 1, so you can send only 15. So outstanding frames can never be beyond that 15. How can you send 15? Even in the buffer 60 packets might be available, but the limiting factor is what? The window size actually. So on what parameters the protocol will depend? Mainly it depends on the realistic values like bandwidth and RTT. Because here only you are going to transmit the packets. Now. When the bandwidth is more, RTT is more, window size will be more, window size more, means you can send more number of packets. It's obvious now when the bandwidth is high, you can send more number of packets. Okay, so what is the answer? B. So remember one very, very important point. Don't think always that outstanding frame, the number of frames which you transmit and waiting for the acknowledgements. Yeah, it is true, but it can never exceed the protocol limitation. Protocol will tell whatever the protocol you fix, based on that those many frames only you can send. You cannot say buffer as a large is there, I am sending 60 packets. No, the limiting factor is the window size. Because of that limiting factor only, because of that protocol only, okay, because of the protocol only you are able to provide synchronization there. Okay, good. B. Yes, everybody understood. B is the answer. Yeah, you can try this question also. Around 2004, 2006, 2008, if you observe the papers, they used to talk about this stuffing techniques also, framing techniques. Okay, let us try to analyze this question also. Yeah, second question first. Yeah, if you observe, okay, it is talking about the supporting techniques you can see of the error control policies. Ishwar, Razak, Soros, Kundan, Kumar, Pratik, very good. So everybody is telling B. See, positive acknowledgements can be transmitted from the receiver to sender if there is an error in the data. Why you send positive acknowledgements? Okay, A is what? Wrong. See, as for the class or any literature, everywhere you observe, only 3 acknowledgements generally we use: positive acknowledgement, duplicate acknowledgement, negative acknowledgement. Positive acknowledgement when you get a data correctly without any errors. Negative acknowledgement if there is an error. This you can use in the error control policy. Duplicate acknowledgement is nothing but what you are sending the acknowledgement again to a sender to convey that possibly the previous acknowledgement is lost. It is something like if the initial hall ticket whatever issued by some authority has been lost, they may issue a duplicate hall ticket for writing the exam. That's called duplicate ACK. Okay, like that. So A is wrong. When flag is a 0610, 10 is added after 5 continuous ones in the data in the bit stuffing. Yes, absolutely. B is correct. Out of character stuffing, okay, character count, bit stuffing. Bit stuffing is an efficient technique because you end up with stuffing less bits and the problem of the framing you can solve it. So indirectly it is a supporting technique to the error control policies. So they don't involve directly in the error control policies, it is only the supporting technique. You can say option C, framing techniques directly provide the error. No, framing technique will never provide. Framing techniques will only act as supporting technique to send the data in small units, so that if by chance something happens, goes wrong, you can detect the errors easily. For detecting the errors, separately CRC is there, checksum is there. Okay, different techniques are there. The framing techniques are supporting things. They make those things to be done in an easy manner. Yes, very good. Okay, B is the correct answer. Excellent. Everybody has given correctly. Yeah, you can try this question. So even like error detection, error correction, we have done many problems in the class. They may ask a small twisting also. See, such a small model they have given sometimes like this. Okay. To detect a D errors, the minimum Hamming distance should be D plus 1. To correct D errors, 2D plus 1. Okay, like that. For detecting, distinguishing the invalid code word from the valid code word is enough. For correction, it is not only to convey that whatever you got, it is an invalid code word which is not within with a valid one. And whatever the invalid code word you got, from that you have to uniquely find out the valid code word and eliminate the n minus 1 valid code words. For that you require a distance 1 more D. So 2D plus 1 for correction, D plus 1 for detection. But here we are not asking that question. Just analyze the question and tell me the answer for it. So simple, okay. For example, so simple. See, suppose if I take a 2 bits as simple logic, 2 bits 0, 0, 0, 1, 1, 0, 1, 1. If you observe these two, because these are the maximum bits that differ, Hamming distance is 2. What is Hamming distance? Number of bits that differ each other between the code words. You can see distance is 2. That means when you take a 2 bits, the maximum distance is 2. So when you take 8 bits, maximum distance will be how much? 8. So C is the answer for it, like that. They can give like this also, some logic. Whatever the knowledge is we have learned, in the application point they can give in this way also. Answer correct. Vinay, very good. So minimum cannot be a 0 because you can't take the same code words and find out. Minimum 1 should be there. You take any code, say 0, 0, 0, 1, 1. 1 should be there. No? You can't take the same code words because the Hamming distance itself rule is what? The number of bits that differ between the two code words. You can't take a same code word now. If you take a same code, always the Hamming distance will be 0 only. Okay, Soros? Good. Okay. Good, very good. Yeah. Now see this particular question, when you are learning the network layer and then the transport layer, so the different attributes we are going to learn: IP address, port address, identification number, okay, the sequence number. Now based on that only some attribute question they are asking. Don't solve it immediately, think logically what they are asking and then apply. This is also MSQ question. Yes, Ishwar, Hamming should be 1. Yes. Okay, so here they are saying that which of the following is true with respect to port numbers, say port numbers and protocol field. So think logically, where the port numbers will be there in the TCP header or UDP header, source port and destination port with the 16 bits will be available. Where does the protocol field be available? In the network layer header, especially in the third row, after TTL there is a protocol field. Okay, now you try to analyze, you will get the answers. Anusuya, Suraj, Hari Krishna, Nad. What they are saying that in the case of okay, option A, application layer protocols like HTTP, DNS, FTP, these are application can be identified and distinguished by the protocol field. This is wrong, no? Okay, protocol field will be available in the network layer. Application protocols can be identified by the port numbers. Yes, very good. So B is the one of the answer actually. Okay, this port address will tell you. For example, say HTTP 80, HTTP, okay, DNS 53, FTP 21 and 20. So these ports will give you which application you are using at the application layer. Next, transport layer protocols like TCP and UDP, and network layer protocols distinct with protocol field. Yes, protocol field will tell you about it because available in the network layer. Out of all the protocol fields, if you observe protocol field number 1, then that is called it as a ICMP packet. Okay, like that. And you can see both TCP and the IP protocols, they are distinguished with port number. It is also false, you can say. So what are the answers? So B and C are the answers. So you cannot say one number for the other. When the attributes are clear, so you can easily analyze a network what is happening. Okay. So the format header is given in the hexadecimal. After TTL, the protocol field will be there usually. Okay. That you have to observe. Yes, you can solve this routing algorithm question. Yeah, try this question. 5th question. Yes, Answer correct. Hari Krishna, good. Nad, Vinay, very good. ईश्वर both the fields will be given ईश्वर after TTL definitely protocol field TTL का role अलग है protocol field role अलग है TTL will tell you how many hops it has to reach when does the packet has to drop protocol field will tell you what is the reason behind that packet is dropped. Okay, fine. So generally what are the rules of this routing algorithm? Initially routing tables will be emptying and every router will be knowing the information of what directly connected routers. Once the routes are converged, okay, every router will have the final cost actually, or you can say as the time progresses, the estimated cost will converge towards what? The final cost, whatever might be the routing algorithm. Because you always find the best path by using the matrix. You try with initially with a delay. If you don't find, if you get an ambiguity, go for a hop. Again, if you get an ambiguity, you can try for something else like bandwidth. Okay, fine. So you can see here the network is given as what? A, B, these are the routers, which are the 3-layer devices, A, B, C and D. So 4, 1, 1, 1 are the delays they have given. Okay, see once routes are converged, means what? What is the meaning of routes are converged? All the routers will be knowing the information of all other routers and those are the minimum cost you can say. A to the, okay, all the routers will not use path A to B as 4. Yes, you can see initially A to B is 4, but as the time progresses A to B via this C will be 3. So this is the estimated cost and this is the final cost. So this estimated cost will not be used as the time progresses. So that is true. So you can say A is the correct answer. Okay, like that. A is the correct answers. Rohit, you have to check your answer, Rohit. Asuna, very good. Hari Krishna, Patedar. Router A will get the minimum cost path to all routers by applying the delay as the metric. Yes, you can see 1, 2, 1, 1, 1, 3 and it is 4. So using delay only you are able to solve. So here B is the correct answer. See, if you get a ambiguity with a delay, then you go for a hop. Ambiguity means what? From one router to other routers. If the equal delays are there, then you can try for a hop or something like a bandwidth. But when you are able to solve with a delay only, no need to go for a hop or a bandwidth. Okay. So what are the answers? A and B are the answers. When you are going to use a hop, when you get an ambiguity with a delay as a metric. Okay. The answer is what? A and B. Vinay, very good. Ishwar, very good. Yes. Yeah, you can try this one more question. Okay, so try this sixth question. Very good. Vinay, Ishwar, very good. Kundan, good. Abhirup, Shane Gupta, good. Yeah, they are asking this question regarding supernetting or address segregation. So logically the table size reduced, so the searching time is less and the packet will be forwarded fastly if supernetting is applied. Yes, it is true, na? So table size automatically is going to reduce. That's true. Anushuya Mahapatra, good, ABC. Power of two networks can be joined to formula. Yes, it is also correct. When supernetting is done, then the number of hosts of entire supernet will be more compared to a network. It is also true. The main idea of supernetting is increasing the number of hosts, because when you join the network, if you take one class C network 254, other class C network 254, if you join them 508, so obviously it is more than the actual single network. So all are correct. So A, B, C are the correct answers. A, B, C. Good, very good. Yes, try to solve this problem. It is regarding the timer, persistence timer, whatever you are going to use in the case of what? A TCP. The case of TCP. It's quite logical question. Shall I give the hint? It's so simple. So when there is a sender TCP, the other one there is a receiver's TCP, you can see. So whenever during the data transmission, in the case of ACK, whenever the window size is 0, the receiver is telling to the sender TCP, I don't expect any data because my buffer is full. Then in that situation, here it can start a persistence timer. But remember, after starting this persistence timer, it is only going to wait, only bounded waiting. It is only waiting, it will not do nothing, only bound waiting initially. Might be, I have taken a 30 seconds, it is going to wait for it. So you can see persistence timer is started and probe segment is transmitted. So this becomes wrong, A is going to be wrong. Because you can see persistence timer is started and only waiting, it is not sending any probe segment. So A becomes wrong. Everybody please observe that one. Everybody here, you put an answer as A. I know you are going to give this answer wrongly, that's why I have given this question. A cannot be the answer. Please observe the question, persistence timer and the probe segment is transmitted. Where is the probe segment? Nothing, no. So you have to observe the statements clearly also. Okay, now here you see, you start timer for 30 seconds. So next one more ACK with a decent window size, say for example some 40 bytes. Okay, it is transmitted by the receiver, indirectly telling the sender TCP, please send next 40 bytes. Suppose at a time t is equal to some 5 seconds of this timer, at time t is equal to 15 seconds of a timer. If this ACK is lost, you know there is a possibility of what? Deadlock. Here there is a possibility of deadlock. Yes. Now you tell me, then 15, 16, 17, 18, at 30th second it is going to expire. Then once again now you will start a persistence timer. Once again you will start a persistence timer. Now you start sending the probe segment. This is the very important logic. So first time you don't send a probe segment, only from the second time onwards. Okay, based on that, now you analyze that question, you can solve it now. Try. Yeah, persistence timer is started to overcome what? Deadlock. That is one of the answer. Good. Try with the remaining options. See, initially you put everybody A because you know the logic, but see, when you try to apply, you find now that A is wrong. Okay, like that. Now see, persistence option B. Persistence timer is started whenever the receiver TCP sends ACK with a window size 0, and if the next ACK from the receiver is lost, then once again persistence timer is started and the probe segment is transmitted. Yes, it is correct now. So B is correct. So persistence timer will not be started, so C is also wrong. So what are the answers? B and D are the answers for it now. Yes, now you are done correctly. Hari Krishna, Sen Gupta, Soras, Kundan Kumar, Raman Singh, Ansuya Patra. So I have given the question in such a way where you end up with wrongly like A, which is wrong. So B and D are the answers. Okay. Ankit Patel, good, very good. Yeah, you can try this TCP one more question, 8th question. Take some time and solve it. Yeah, these are the basic fundamentals, but they mix this question in the case of TCP. Try. 8th question. Option is PSH segment can be used for sending interactive data and data need not be buffered at sending. Yes, it is true. Whenever you want the response should be fast, interactive data, we can use the PSH segment. So it's correct. It's correct. Window size and TCP for synchronization between sender TCP and receiver TCP. It is also correct now. See, whatever the ACK that is transmitted by the receiver TCP, in the ACK window size will be there. With the help of that window size only, sender will be knowing how much data receiver is expecting. That much data only you are going to send. That is for synchronization. Otherwise, sender will send and the receiver will get a buffer overflow problem. So that window size used for synchronization, it's correct. Vinay, correct. Ankit, Suna, very good. Next options, initial connection establishment from sender TCP requires a random number from a range 0 to, yes, it is also correct. Yes, if it is a data link, it might be 0, but it should be a random sequence number. For what purpose? For providing security to the data. Okay, for providing a security. So A, B, C, these three are the answers for it. Good, very good. Ishwar, correct. Kundan, Anusuya, Soras, Hari Krishna, Raman, Sen Gupta, Patel, Asuna, very good. Yeah, you can try one more this TCP question. They are asking regarding the checksum they are asking. Okay, try. You can TCP checksum. Yes, Raman Singh, correct. Data for data security. Ishwar, you asked the time wait timer. Na? What is the purpose of time wait timer? If any delayed segments you want to expect after the fin segment, because the fin segment whatever you transmit indirectly telling to other person, I am closing the session with this so and so sequence number. लेकिन कोई delayed segments भी हो सकता है. If any delayed segments are there, they should be expected by that sender receiver. इसलिए थोड़ा time wait करना चाहिए. So it has to wait for some time. So that wait time is called time wait timer, which is a 2 into MSL time. So you ask for the time wait timer. Na, any lost segments are there, any delayed segments are there. To accept that, they wait for the time wait timer. But persist timer is to overcome the deadlock. okay, like that. Okay, I hope you understand. Okay, Ishwar. You can say sender, the destination and the router. TCP checksum is calculated at sender side and at a router TCP. So A is wrong because you know TCP provides end-to-end calculations only. At routers or in between LANs, they will be taken care by the IP header and the CRC. So A is wrong. Next, if you go for option B, TCP checksum is calculated at sender side and a destination TCP checksum again calculate verification and accepting segment. Yes, it is correct. Okay, end to end, because TCP provides a process to process delivery or end to end delivery, it is going to provide. And you can see option C, TCP checksum is calculated sender side after CRC calculation. For example, see at the sender side application layer, then transport layer, then network layer, then data link layer, then physical layer. And you know at data link layer CRC are going to get a transport layer, here you are going to get a TCP checksum. So you can see the data will start from above to lower value. So this TCP checksum is calculated before the CRC only, but you can see it is calculated after CRC calculated. It is wrong. So C is wrong. So what is the answer? Only B is the answer. Yes, Ishwar, correct. Raman, Kundan, Nath, Patedar, Sen Gupta, Hari Krishna, Soras, good. Ankit, excellent. Good. Okay, so try this question. They are asking regarding the distance vector routing, and they are asking which are the false statement. Remember this one. If they ask some little twisting, they can ask in this a false statement they are asking. Try this one. So whatever I have given the different model questions, such like different models, some questions will be lengthy, some twisting, okay, some questions will be small answer, such type of different standard models. I have all given all the questions in the rank improvement batch workbook. Okay, most of you know what, whoever attended the batches, whatever I taught you, you have solved it. So in that book I have given all these standard models, and here these are the different other questions also I have mixed and have given. Which are the previous gate, where exactly the logic is missing, that I have explained. Very good, Ishwar, good. Sen Gupta, Hari Krishna, Suraj, Srinivas, you have to check your answer. Raman Singh, good. So you know these three are the properties of the functionalities of the distance vector. Okay, so all are correct only. So what is the answer? D is the answer for it. It is an iterative algorithm, distributive, asynchronous algorithm. These are the properties of the distance vector routing. Arvind, good, very good. You can try this one. Overall average throughput of TCP can be increased. See, they are asking overall. See, let me explain this question. See, actually, you know, when we discuss the conjunction policies of TCP, the conjunction window will be less than the receiver's window. Then only you will apply the conjunction policies and you transmit the data in the form of MSS. There, if you try to analyze, we start with slow start, then conjunction avoidance, then conjunction detection. So, slow start is exponential. It will be 1 MSS, 2 MSS, 4 MSS, 8 MSS like that. When you go for conjunction avoidance, it's a linear increase. Okay, growth is linear. Okay, like a sawtooth waveform will be there. But when you apply all these rules every time, if the timer expires slow start, if there is a weak possibility conjunction avoidance, if you as you observe that the overall throughput, it's not a single throughput, overall throughput is going to decrease. So what TCP in the new versions patchworks they have done, they have removed that the slow start, only additive increase and multiplicative decrease they have taken. Then the overall throughput it is increased like a sawtooth waveform. Increase, something happens, fall down, increase, again fall down like a sawtooth. Then overall means the average throughput is going to increase. Okay. So here the answer will be what? B is the answer for it, because this is something new. So why slow start is not included scenario means, if you take a slow start, none. The point is even the word exponential growth is telling that moving fastly, but remember it is 1, okay, 2, 4, it is starting with 1 MS, that is the main problem. So when you start with 1 MSS, overall throughput is going to decrease. That means, you know, when the timer expires, it is a strong possibility you start with 1 MS and you go with the exponential. Even the word is a twisting like exponential, it might be fast. Since it is starting with 1 MSS every time, the overall average throughput is going to decrease. So in the extended version of TCP, if you remove that, you use only additive increase, something happens, multiplicative decrease, then average throughput is going to increase actually. So for this, the B is the answer for it. Okay. Yeah, threshold will be half, but threshold will be half, Ishwar. But you start with 1 MS, that is a problem. So then in the conjunction avoidance, that is not a problem. No, because why you start with half at the sender window, initially start with half, and there you start increasing linearly. You observe the additive increase. When something happens wrong, you make it half, and from that half you start analyzing the sender window size. Okay, that's the reason. Yeah, I hope now you can solve this question. Try. Is one of the important model also. Try this question. Yes, Raman, good. Yes, Ishwar, Raman, Nad, Soras, Roy, everybody is telling it is C. Yes, correct. So C is the answer. So this is one of the very important logic. Even the DHCP purpose, it is to get a IP address. You might be in illusion thinking that is a network layer protocol, but since it is coming as a application software, it will work in the application layer. And how you distinguish from the remaining application layer protocols? In all remaining application protocols, source port will be dynamic port, destination will be fixed port, but especially, or vice versa it might be there, but especially this DHCP both will be fixed ports. 67 and 68 are the port numbers. So here you can say for this one C is the answer for it. Good, very good. Yes. Yeah, so these are some of the questions related to the periodic timer and trigger update timer. So the basic inputs is what? Normal in the routing algorithms, what timers they use? Periodic timer, the other one the trigger timer. What is the purpose of periodic timer? To know the status of a router, whether the router is up or router is down. What is the purpose of trigger update? It is know the status of a link, whether the link is connected or disconnected, you can say. This is, they are asking logically, what will happen if you depend on the periodic timer instead of the trigger a bit when link is broken? This is a one analysis question, you can say. You have to think logically and you have to give the answer for it. Ishwar, good. Jubair, you have to see your answer. Ashuna, correct. Very good. Loss of data packets will be high. Yes, very good. How anybody can say? So simple, because periodic timer will have a timer once when the link is broken, and if you entirely depend on the periodic timer, and then after 6 microseconds or 7 microseconds, whatever the timer values, during that time, whatever the packets that are coming from the upwards, all the packets will be lost. So you can't make the packet loss as a minimum. So this you can make it a minimum only with the help of trigger update, which is immediate and it is instantaneous. Otherwise, if you purely depend on the periodic timer, loss of packets will be high actually. Okay, so you can say A is the answer for it. Good, very good. Kundan, good. Soras, very good. Soras, correct. This is also one application question. You try. IP protocol fragmentation fields they are asking. It's like a pseudo header, regarding to pseudo header they are asking. Ishwar is telling, sir, in the link state routing a node transmits. See, Ishwar, a node will not transmit. Root router will send the entire table. So you are asking question, sir, in the link state routing algorithm, does a router will send the entire table? No, the root router will send. First of all, for the root router, all these routers will give the LSP packets and it will create the LSDB packet. So root router will give the complete information, not all the routers. Okay, Ishwar? Remember, it is a hypothetical network. We are not going for IP net protocol. The IP protocol total length is 16 bits. Fragment offset is 13 bits. Difference is 3. 2 power 3, 8 is playing the role. But it is a hypothetical network. So it is mentioned that fragmentation bits are also 16. So you can see it is mentioned that fragmentation bits are 16. Total length is also 16. That means it is a design network they are asking. You have to think and tell me. So that's why these are called application questions, you can say. You can't say the element. Okay, in a generalized the difference is 3, 2 power 3, 8 is playing the role. Very good. What is the answer? Yes, A is the answer for it. Fragment S of is equal to fragment bytes. Soras, correct. Ishwar, Roy, Patel, good, very good. Yeah, and last 3-4 days back, another student has asked me a question regarding sir, wraparound time. Sir, while calculating a wraparound time, when you observe the gate key like that, sir, they are giving the normally the bandwidth will take it as a multiple of 10. Like kilo means 10 power 3, mega means 10 power 20 like that, giga means some 10 power 9 like that, mega means 10 power 6. But in that solution they have taken a 2 power something. Sir, what is the logical reason? So I used to explain in the class also, if you remember, when you store data in memory or cache memory, hard disk like that, they store in a binary power of 2. But when you transmit, it is always in the kilo means 1000 only, mega means 10 power 6 only. Then you are asking, then why we use that, they use the 2 power, why not 10 power means? See, the logical reason in that question, this is a last year question actually, because there is a 1 bit difference. Okay, in that question actually, if you observe TCP, you know the wraparound time, the sequence bits they are providing the 32 bits, and you know very well in the TCP segment is nothing but what, group of bytes. And for every byte, we are going to assign the sequence number. So the most important point is that protocol is designed for the binary bits. That's why they are taking the bandwidth as power of 2. Okay. Otherwise, normally kilo means 1000 only, 10 power 3 only. So in the wraparound calculations, when we are calculating that value, why the bandwidth they have taken in the power of 2 in the previous gate questions, if you observe, this is the actual reason. If you remember, in the case of TCP, sequence bits, how many they are provided? 32 bits. How many sequence numbers are possible? 2 power 32. Okay. Sequence numbers to whom you are going to assign, one sequence number is assigned for 1 byte. Then 2 power 32 sequence numbers will be assigned for 2 power 32. So that is the actual reason they use the bandwidth also power of 2 only to what you can say, indulge with that protocol. You know, units and dimensions in the physics, when the numerator will have a same units, the denominator also will have a same units, or the left and right will have a same units. This is the actual reason in the numerator when you use something like a power of 2, there the bandwidth also they are using as a power of 2. I hope this answer will give you the clear answer. I think in the 2022 one question and some 2016 also this wraparound question they have given. Okay. No, stop and wait, how the pipelining will be made? Stop and wait is a special case of go back and ARQ. In stop and wait ARQ, only one frame is transmitted actually. Okay, Ishwar? Good. Yeah, wraparound questions. So bandwidth means in such type of questions, when they ask in TCP, you take it as a 2 power only. Otherwise, normally 10 power 3 only. Because wraparound time they ask in the case of TCP. Okay, good. Yeah, these are some these are some models of subnetting, how to calculate a subnet ID and the subnet number. So basically we have covered the whatever the different twisting questions we have given, and if you observe that workbook of the rank women, you can find almost such type of questions, and for the revision of all the concepts you can go for the QRC program also. Okay, I hope you enjoyed this session. Okay, you can calculate the subnet ID and subnet number. It's okay, calculate. It's very simple, na? The subnet mask they have given. Calculate. Yeah, I think somebody is asking one question. Normally in the application layer, one of the year they ask regarding persistent HTTP, non-persistent HTTP. In some of the year they used to ask about FTP, like the mixing of the question they used to ask. Okay, for one more question. Okay, subnet ID how to calculate? See, it is given as 202.88.99.42. 202 is given, it is what? Class C. What is the mask here? 255 means what here? 8 ones. Again 255 means what? 8 ones. Again 255 means what? 8 ones. 240 means what? 4 ones and 4 zeros. Since it is a class C, these all are the network bits, and these 4 are the subnet bits, remaining 4 are the host bits. Okay, like that. So some last words, whatever you have worked for 6 months or 1 year or 2 years, it's enough if you are very thorough with the basic fundamentals. Okay, the fundamentals are the most important for solving any question actually. Okay, whether it's a network or some other subject, 1 or 2 questions might be a small twist will be there, but remaining all questions you can easily solve it, I hope. Okay. because the boundaries will be there. They can't go beyond the such boundaries actually. When we are covering all the maximum boundary, so within that limitation only the questions can be given. Yeah, subnet ID means you can say it is a 42, na? So I can write like this. See, this 42,001 is 32. 10 means what? 1010, like this I can write. So you can say 4 bits are subnets, 4 bits are host bits. So this is the subnet and these are the host bits. So they are asking subnet ID. So 0010 is the subnet, and for a subnet ID host bits are all zeros. So here these are all zeros. So what is this particular value? It is 32. So I can write like this: 202.88, okay, 99, and then 40 and then dot 32. This value is 32. Okay, and the subnet number. What is subnet number? 0010 means what? Second subnet, you can say. Okay, second subnet, because this value is 2. Second subnet. Okay, so you always focus on the fundamentals. The fundamentals are the most important. When you are strong with fundamentals, okay, standard questions you can easily solve, and you whatever any analysis question you can do analysis at that moment, and immediately you can solve it. Almost 60 to 80% network questions will be direct questions will be there. Okay, remaining 1 or 2 you have to do some mathematics like this. Okay, all the best, all the best. I hope you enjoyed the session. Okay, if any further questions you can see in the rank improvement workbook. Okay, thank you all. Nice it is interacting with all these people: Suraj, Ishwar, Ankit, Kundan, Raman, Ishwar, Sen Gupta, Ishwar, Ankit, Ajay, Devesh. Thank you so much. Thank you all. Thank you Ankit, thank you Raman Singh, thank you Ajay, thank you Devesh. Thank you very much. Okay, bye bye. I can.